back in the olden days, how they would calculate the sine, cosine, and tangent of a function is by drawing a triangle and find the ratios of those two sides. So they would go out here, measure, oh, if this is 50, then this would be 1.7, 1.53, and this is 2. So we can say that the sine of 50 is equal to 1.53 over 2. And honestly, it's really precise work and it is really annoying to do. But luckily, we have evolved. We don't need to draw triangles to figure out the sine, cosine, and tangents anymore. We have calculators. So, on your calculator, you have these functions, sin, cos, and tan. They stand for sine, cosine, and tangent, respectively. If you put in sine, cosine, or tangent, if you give them an angle, then it will give you the ratio of those sides, or the respective sides, SOHCAHTOA. So, let's do a few examples onto your calculator. Now, make sure your calculator is in degrees mode. A good way to test if your calculator is in degrees mode is to do sine of 30, like we were doing earlier. You should get 0.5. Now, if you don't get 0.5, I would recommend Googling your calculator model and number and figuring out how to change it to degrees mode. Because for Math 10, generally it is in degrees. All right? So let's do some practice questions. These should be pretty simple. You can pause the video and give it a try and just put in these into your calculator. All right, so sine of 25 is approximately 0.42. Now, put the approximate sign because this is a long decimal. So usually just capping it at 2 decimal places is enough, but if you are cutting off at any point, make sure you put the approximate sign. It looks like a squiggly equal sign. All right, cosine of 74, that is approximately 0.27. And tangent of 80 is approximately 5.67. Now, don't forget what these really mean. What this really means is that if you have an angle of 25 degrees, the opposite to the hypotenuse is 0.42. Basically, what 0.27, what this means is that the ratio of the adjacent to the hypotenuse is 0.27. And again, with the tangent, the ratio of the two sides is 5.67. Don't forget that these are ratios. They're not just random numbers that come out of thin air. It's very important that you understand that these are ratios and that these apply to all triangles no matter how big or small they are, as long as they have that angle. All right, so let's use our understanding of these new functions to solve some triangles. Here are some examples. Up here are some reminders. Sine is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is equal to opposite over adjacent. Now, it says find x. Most of the time, triangles will not be to scale. So if your teacher says to find x, I wouldn't recommend grabbing a ruler and trying to measure out x. 99% of the time, it will not work. So make sure you use these trig functions instead of grabbing a ruler and trying to measure it. All right. So right here we have a triangle with 29 degrees. We see that the opposite side is 3. And it also has an adjacent side of x. We don't know what x is, but let's try and find it. I wonder if there's a function that has the ratio of the opposite to the adjacent. Well, it's not sine, it's not cosine, but it's tangent. So what we can write out here is that we can say that the tangent of 29 is equal to the opposite over the adjacent, 3 over x. Okay, now let's just solve for x. A trick you can do is that if there's a number in the denominator, there's one up here, you just flip it, and you can write x is equal to 3 over tangent 29. And you end up getting 5.41 approximately. Okay, Let's try another example. Okay, so now we have a triangle with an angle of 49 degrees. We have an opposite that's equal to 4, and we have an hypotenuse that is equal to x. Okay, so is there a ratio of an opposite to an hypotenuse? Oh, it's just sine. So we can write sine of 49 is equal to 4 over x. Once again, we can just swap these two. We can get x equals 4 over sine 49 and plug this into our calculator, and we get approximately 5.30. Okay, let's do one more. So here we have an angle of 79 degrees. We have a hypotenuse of 9, but we have an adjacent of we don't know what. So let's see if there is a ratio of the adjacent to the hypotenuse. Oh, right over here, the cosine. So we can write cosine of 79 is equal to x over 9. Multiply both sides by 9, and we get 9 cosine of 79 is equal to x. And we end up getting 1.72 as our answer. Right. Here's a summary because that was a lot of information, I agree. But yes, the side opposite to an angle is called the opposite, the side next to an angle is called the adjacent, and the longest side is called the hypotenuse. So don't forget that, that's very important. Next thing is that we have sine, cosine, and tangent, which allow us to figure out the ratios of the sides of a right angle triangle. So don't forget, it's ratios, very important word. Now, sine is the ratio of the opposite to the hypotenuse, cosine is the ratio of the adjacent to the hypotenuse, and tangent is the ratio of the opposite to the adjacent. Or, just remember, SOHCAHTOA. Alright, if you want to find a ratio of an angle, make sure it's in degrees mode, very important, and put it into your calculator. So, alright. Now, to solve for sides on a triangle, identify what ratio is on the missing side, or what's the ratio of the missing side to an angle that you do know with respect to an angle, and after finding a trig function that describes the relationship, use this trig function to solve for x. That's just a lot of words, but really what this means is find the ratio from earlier. So up here for the example, what I was really trying to do was just find a ratio of a side I do know, which is, for example, the first one, the opposite, but I don't know the adjacent. So I'm trying to find a trig function that has the opposite to the adjacent. And, oh, that's tangent. And I use this tangent ratio, or this tangent function, to help me solve for x. That's really what it just means. Alright, some other notes. The hypotenuse is always bigger than the adjacent. Always. Don't mix them up. Always remember that the hypotenuse is bigger. Now, theta is a variable for an angle. It's not a fancy term. If you think theta, it is really similar to x. It's just a variable. Now, unless you get a definite answer, all your answers will be approximate. So use that squiggly line thing. Don't use the equal sign unless it is an exact answer. Now, most of your answers won't be drawn to scale, so don't try to measure the sides. Use the trig functions. Now, last one is if you're given multiple sides and angles, you can choose which trig function to use, as long as one of the sides of the ratio is the missing side. So, here's an example. If I have a triangle out here, and it is 53.1, and it's 3, and it's 5, you can write, or if we're trying to solve for x, you can write sine of 53.1 is equal to x over 5. That works, and you can solve for x by multiplying both sides by 5. Cancel out. That works. Or you can also do the tangent of 53.1 is equal to x over 3, the opposite to the adjacent. So you can multiply both sides by 3. That works out just fine. What you can't do is you can't do the cosine, because the cosine of 53.1 is the adjacent to the hypotenuse. That's 3 over 5. That's correct, but we're trying to solve for x. That doesn't really help us. So it doesn't matter which one you use. If you have multiple different sides or multiple angles, it doesn't matter which one you use. You're trying to, as long as you're able to solve for the missing side. And that pretty much wraps up this trig video. Next section will be on the inverse trig functions. If you have any questions, you may always email me, and I will try to get back to you in a timely manner. And this is Low Academy signing off.